Hello, welcome to our session. Today, we are entering into the human physiology part. We know in human physiology, we are discussing the nature of our body. We are all having organ system grade of organization. We are having 10 major organ systems, of which the first one we are now going to study is digestive system. See, no organism can live without energy. For all their activities, they require energy. And that energy is coming by the oxidation of the food material. Plants will prepare their own food material. There are autotrophs, but that is not the case with animals. They have to get it from outside. So animals are heterotrophs, and we are no exception to that. We will be taking food from outside, then digesting in our alimentary canal, and the digested food is absorbed. And we have definite stages. First, we have to take food into our body. Through the mouth, we will be taking. That is called ingestion. Then, in the alimentary canal, it is digested. So, digestion occurs extracellular, outside the cells. Then only these digested small molecules are absorbed into the cells. So, absorption takes place. After absorption, they are all reaching different cells, tissues of our body, which will be utilizing them. That is called assimilation. Utilization of these absorbed nutrients for their activities is called assimilation. After that, what is remaining, which is not at all digested, will be sent out of the body. That is called egestion. So, in the typical alimentary system of organisms, we are having 5 stages occurring: ingestion, digestion, absorption, assimilation, and egestion. We are also having all these stages, and these are all performed by a group of, a system of organs which are all organized to perform this function. That system is called digestive system. Our digestive system consists of a long, highly coiled tube called alimentary canal, and associated with this alimentary canal, you are having large number of glands, both inside the alimentary canal and outside the alimentary canal. They are associated glands. They are associated with the digestion. So, digestive system consists of alimentary canal plus associated glands. Alimentary canal is starting from mouth. We have a complete alimentary canal, meaning having 2 openings. The anterior opening is the mouth and the posterior opening is the anus. So, alimentary canal is a long coiled muscular tube which are all modified into different regions to perform different functions. Okay, the first part that mouth opens to is called oral cavity or buccal cavity. This oral cavity is protected by means of jaws, which are all bearing teeth. In mammals, see, we are all mammals. In mammals, there are some special features for the dentition. What is dentition? Arrangement of teeth on jaws. We can simply say that our dentition is thecodont, meaning teeth are kept in sockets. In the jaws, you are having sockets. Inside these sockets, you are having the teeth placed. Okay, they are all fixed there, strongly cemented there. Okay, so this is called thecodont. Only mammals are having thecodont dentition. And all our teeth are not uniform, not of the same shape and of function. We have different types of teeth. That is what is called heterodont. So thecodont, heterodont, and these teeth are appearing in two sets. We are having two sets of teeth appearing. What are they? During the early childhood days, we will be having one set of teeth appearing. This is called milk dentition. And later on, these teeth will be falling off. Since they are all falling off, they will be also called by okay. So we are having two sets of teeth, which is milk dentition and the second set of teeth will not fall away. That will be remaining almost throughout the end of our life. That is why it is called permanent. Since the first set of teeth are falling, it is called deciduous. Deciduous dentition. That is falling off. Each half of our jaws are having the same number and type of teeth. Okay, because we are having bilateral symmetry, each half of our upper as well as lower jaw are having same number and type of teeth. What are the types of teeth? Normally, we will be having 4 types of teeth appearing in permanent dentition. They are all incisors, the flat, thin, chisel-like teeth. Canines, which are all sharp, longer type, which are used for tearing. Premolars are smaller teeth with a flat surface, and molars are larger, also with flat surface. Okay. They are all used. Premolar and molars are used for grinding. So conveniently, we can call them together as grinders. So the 4 types of teeth are incisors, canines, premolar, and molars. And we can arrange the different types of teeth and their number in the form of a formula called dental formula. In dental formula, we are taking the number of each type of teeth present in one half, only one half in each jaw. So, if you take the milk dentition, we can see that in milk dentition, incisors are 2 by 2. Why we are writing 2 by 2? The denominator will be the number of teeth in the upper jaw. Denominator represents the number of teeth in lower jaw. So each half is having 2 in each half. Canines. So incisors 2 by 2, canines 1 by 1. Premolars are not developing. So it is 0 by 0. And molars are 2 by 2. This is the milk dentition. So total 20. Okay. Whereas in permanent dentition. See, these teeth will be developing by the age of 2 or 3, and they will be falling off between 6 to 8. And instead, you will be having the second set of teeth coming. This is called permanent dentition. In permanent dentition, the formula is slightly changed. Incisors are 2 by 2, canines 1 by 1. There is no change for that. Premolars are making their appearance 2 by 2. And in molars, there is an additional one appearing. That additional last set of molar is called wisdom teeth that appear a bit late. Many of you at this age of 17 or 18 may not have that teeth appeared. It may appear by the time you reach 18, 20, like that. That is why it is called wisdom teeth. The last set of molar is called wisdom teeth. So, understand, what is the total number of teeth in permanent dentition? It is 32. So, what teeth are not represented in milk dentition? They are the wisdom teeth and premolars. So, premolars and the last molar are appearing only once. Since we are having two sets of teeth, normally our dentition is called diffeodont. Di means two, phios means set. So, having two sets of teeth. Whereas the premolars and the last molar, that is the wisdom teeth, are monophyodont. We can again say that the premolar and the last molar, wisdom teeth, are having no predecessors, no representative in milk dentition. They appear only in permanent dentition. Okay. The hard chewing surface of the teeth is made up of enamel, which is the hardest material of a body, and with the help of the flat surface of the grinders, we are all grinding our food. Now, lying in the floor, you are having tongue, a highly movable muscular organ. It is connected to the floor of the buccal cavity by means of a fold of structure called frenulum. And on the surface of the tongue, you are having small projections. These projections are called papillae. And some of them will be bearing, not all. There are 4 types of papillae and 3 types will be bearing the taste buds. Taste buds are not only present on the papillae but also on the surface of the tongue. Don't think that taste buds are present only on the papillae. No. Papillae are projections that are arising from the surface of the tongue, and they may bear. Most of them will be bearing taste buds. Taste buds are also present on the surface of the tongue. Now, from this buccal cavity leads a short pharynx. What is that pharynx? Pharynx is the common chamber to which our buccal cavity and nasal chamber are opening. So, it is a common passage for food and air. From that, you are having 2 passages. One leading to the trachea. That opening is called glottis. The other one, vestibule, that will be leading, vestibule is also called gullet, leading to a muscular tube called esophagus. Okay, so there's a cartilaginous part called epiglottis. This epiglottis is covering the glottis so that food particles are prevented from entering into the trachea or respiratory tract. That is a characteristic feature of mammals. Okay, so esophagus is a thin, long, muscular tube that will be passing through the neck on the back side. That is, ventrally you are having the trachea. It is lying just back of the trachea. Passes through the thoracic cavity, and there is a diaphragm here, separating the thoracic cavity from the abdominal cavity. Okay, and this esophagus pierces, passes through that diaphragm. See, you are having a diaphragm here. Esophagus pierces the diaphragm and enters into the abdominal cavity, and it leads to a chamber called stomach. Is that clear up to that? Now, coming to the stomach. Stomach is the widest part of the alimentary canal, which is a J-shaped structure, whose walls are thick and highly muscular. Stomach has 4 parts. What are they? Stomach is having 4 parts. 1. The part to which esophagus opens is called cardiac stomach. It is called so because it is close to the heart, and the stomach is having a raised part called fundus. It is always filled with a gas. The main part of the stomach is called body. The posterior part, the continuation of the stomach, become narrower, and that narrow part is called pyloric stomach. This pyloric stomach is leading to the intestine. Now, we are having 2 sphincters. What is a sphincter? Sphincter means a circular muscle which is acting as a wall. By its contraction and dilation, it may close an opening or open an opening. Such circular muscle is called sphincter. At the point of opening of the esophagus to the stomach, you are having a gastroesophageal sphincter. This gastroesophageal sphincter prevents the backflow of food from stomach to the buccal cavity. And on the inner side of the stomach, you are having longitudinal folds called rugae. The pyloric stomach, similarly, is also having a sphincter. It is called the pyloric sphincter, which regulates the entry of food to the next part, namely the intestine. Intestine has 2 parts. It's a long coiled muscular tube which is having 2 parts. 1, it is small intestine. Why it is called small intestine? Because diameter is small, but length is long. It is longer. Length is high. This is called small intestine, which has 3 parts. The first part, following the stomach, is a C-shaped structure called duodenum. Duodenum is the first part. Okay. A C-shaped duodenum. Then the second part is a coiled part called jejunum. And the third and the last part is the highly coiled and the most elongated part called ileum. So, this part consists of a duodenum, a jejunum, and ileum. That ileum will be leading to the large intestine. Large intestine is shorter in length, but wider in diameter. That is why it is called large intestine. It has 3 parts: a cecum, a colon, and rectum. What is cecum? Cecum is a small blind sac in which symbiotic bacteria are all living. A large number of different types of beneficial bacteria which are all helping us are all hosted on this cecum. From that cecum arises a finger-like structure called vermiform appendix. This vermiform appendix is actually a functionless vestigial organ. Okay. And from that arises the most wide and elongated part of the large intestine, which is called colon. The colon, the first part will be going upward, ascending up. So it's called ascending colon. Bends and is having a flexure on the right hand side, reaches the left hand side, again undergo a flexion or bending and comes down. So we are having three parts for the large intestine. Cecum, okay, the blind sac. Then from that colon arises ascending column, transverse colon and descending colon. And the last part of the colon is a nest-shaped structure called sigmoid colon, by which it opens to the last part, namely the rectum. Rectum is the site where undigested materials are stored till they are all sent out. This rectum opens out by means of an opening called anus. Is that clear? So these are the parts of the alimentary canal. Okay. Now, our alimentary canal is a muscular structure, and it is having 4 different layers throughout it. These 4 layers are: number 1, serosa, a thin outermost layer, which is very tough layer called serosa. Inner to that, you are having muscularis layer, also called muscularis externa, because it is the outermost layer of muscles. And these muscles are in 2 layers. Understand? Outer one is longitudinal, which is running lengthwise throughout the length. Okay. Whereas the second, inner one, is circular in the form of rings around. So both outer longitudinal and inner circular muscles are helping in moving, pushing the food through the intestine. And third, there is a thick layer of connective tissues, in which you are having nerve fibers, lymphoid tissues, fibers, collagen and elastin fibers, and other different types of cells connected with the connective tissue. This connective tissue mass, a thick layer, is called the submucosa, because it is lying just below the outer 2 mucosa. It is called submucosa. And the last and the innermost layer is called mucosa. Why it is called mucosa? Because it is made up of mucus producing goblet cells, which are all abundant in its epithelium. It is the innermost, which lines, which covers the lumen. Actually, the mucosa consists of tall, cylindrical, columnar epithelium, and is having a very large number of mucus secreting cells throughout the alimentary canal. So, a glandular mucosa. And these mucosa are modified into so many different structures in different parts of the alimentary canal. Okay. In duodenum, in this submucosa, you are having a gland called Brunner's gland. In stomach, the mucosa layer is having a number of longitudinal foldings called rugae. And in intestine, you have a large number of minute finger-like structures. These finger-like structures are called villi. They are called villi. Villus singular, villi plural. The number will be so small, the number will be so large that it will be increasing the total surface area within this small intestine enormously. Villi will be having blood supply and also the lymph vessels called lacteal. Okay. They will be helping in absorbing the digested food materials. So, villi are very, very extensively developed, especially in jejunum and ileum. All the cells of the mucosa will be having brush-bordered epithelium. They will be having brush-bordered epithelium, which are all the modifications of microvilli in the epithelium. Also, they will be having mucus-producing, slimy secretion producing mucus glands. These mucus glands are helping in producing a viscous secretion, that is the mucus, which will be helping in smooth contact of the food through the alimentary canal. They are helping in making the food slippery so that it will be passing on very smoothly. Mucosa also form glands in the stomach. In the stomach also, they are all modified. It is the mucosa layer that is modified to form gastric glands. Similarly, in the small intestine, between the villi, you are having small depressions, valley-like structures. Between two hills, you will be having a valley, just like that. Between two villi, you will be having a small tubular structure, which is called crypt of Lieberkühn. This crypt of Lieberkühn are the intestinal glands. So in stomach, you are having gastric glands. In intestine, you are having the intestinal glands, which are all the modification of mucosa layer. But understand, the Brenner's gland is the only gland present in the submucosa. It's a modification of the submucosa, and that is present only in the duodenum. Submucosal Brenner's gland will produce alkaline secretion. What is their role? We are now going to study. Okay. In addition to these circular and longitudinal muscles, in some parts, not in every part, you may have oblique muscles also, oblique muscles. And all the four layers are also showing modifications in different ways in different parts of the alimentary canal. Anyhow, all parts of the alimentary canal are having these four parts: serosa, muscularis, submucosa, and mucosa. Correct? Now coming to the digestive glands, the associated glands. It includes salivary glands, liver, and pancreas. Salivary glands are producing saliva. That is their main secretion. We are having three pairs of salivary glands. The largest one is the parotid gland, which is present at the cheek position. That's why it is called cheek glands. Then a pair of submaxillary or submandibular, which is on the lower jaw, and smallest gland of these three, the smallest one is the sublingual, which is below the tongue. These glands are situated just outside the buccal cavity, but their ducts are opening into the buccal cavity. So their secretion will be coming to the buccal cavity. They are placed outside the buccal cavity, but their secretions are poured into the buccal cavity. Now coming to the liver. Liver is the largest gland of our body. It is having a number of important functions. And it is also concerned with digestion. It is also helping digestion in so many different ways. Let us see how it is helping. Liver weighs about 1.2 to 1.5 kg in an adult human. It is located on the right side of the abdominal cavity. On the left hand side, you are having the stomach. Stomach is on the left hand side, liver is on the right hand side. Okay. It is situated in the abdominal cavity just below the diaphragm and is made up of two lobes, a right lobe and a left lobe. Each lobe is made up of a number of lobules, hepatic lobules. The hepatic lobules are the structural and functional units of liver. In each hepatic lobule, you are having the liver cells. The liver cells are arranged in cords. The cells are called hepatic cells. These hepatic cells are arranged in the form of strings, and they are all covered by a tough covering made up of connective tissues. That covering is called Glison's capsule. Glison's capsule. Okay. This is the structure of a hepatic lobule. Large number of hepatic lobules in both right and left liver lobes. These hepatocytes, that is the cells of the liver, produce the secretion called bile. The bile is carried through their ducts. See, from the right and the left, the right is the larger one, right liver, than the left one. Okay. Arising from the right and the left, you are having a hepatic duct. Duct from liver are called hepatic duct. Right hepatic duct and left hepatic duct. You are having right hepatic duct and left hepatic ducts. These two hepatic ducts are joining to form a common hepatic duct. This is the left hepatic duct and this is the right hepatic duct. Okay. These two joining to form a common hepatic duct. The bile secreted from them will be carried through them and will be stored in a small bladder called gallbladder, which is lying lower to the right lobe. This hepatic duct will be receiving a small duct from gallbladder. That is called cystic duct. That duct is called cystic duct. Gallbladder not only stores bile but also is concentrating. It is keeping them in a concentrated form. Now, from that, you have the cystic duct opening to the common hepatic duct. Thereafter, it is called bile duct. So, bile duct is formed by the joining of hepatic duct and cystic duct. This common duct, common bile duct, comes and open to the duct coming from the second largest gland of our body called pancreas. And at that point, you are having A sphincter. Here you are having a sphincter. That sphincter is called sphincter of Boyden. This sphincter of Boyden will regulate the flow of bile from the liver and gallbladder. Now, pancreas is the second largest gland, which is both endocrine and exocrine. It is both endocrine and exocrine. It is a mixocrine or a heterocrine. 98% of that tissue are exocrine. They produce digestive enzymes. The enzyme is called pancreatic juice. It produces two types of juices. The first set of juice coming out of the pancreas will be containing only water, bicarbonates in it. It is an alkaline secretion. Only the second secretion will be containing enzymes. So they are all carried through their duct called pancreatic duct, which is also called Wirsung's duct. Okay, this duct will be joining with the bile duct and it forms a common hepatopancreatic duct. This hepatopancreatic duct open to the duodenum and there you have another sphincter, a sphincter called sphincter of Oddi. So sphincter of Oddi can regulate both bile flow as well as the pancreatic juice flow. Clear? So pancreas is a compound, elongated organ located in between the two limbs of the C-shaped duodenum. Okay. Now coming to the digestion of the food. Let us see how digestion is occurring. Remember, what is digestion? The food we take is large, complex molecules and it cannot be absorbed directly into our cells. So it is to be converted into the smallest forms. The conversion of large, unabsorbable and unassimilable component of the food into smaller units so that it can be absorbed and can be assimilated is called digestion. Excuse me. Digestion is both mechanical and chemical. In mechanical digestion, we are cutting the food particles into smaller and smaller size so that surface area is increasing. It is only a physical process, whereas it is the second part, that is the chemical digestion. Actual breaking of macromolecules into simple molecules are taking place. For that, we require enzymes. It is an enzymatic chemical process. All digestive enzymes are hydrolysis, meaning they break the macromolecules in presence of water. Hydrolysis. All enzymes are hydrolysis. Okay. So when we take food into the buccal cavity, first there are both mechanical, that is physical, and chemical digestion taking place in the buccal cavity. It is called buccal digestion. It has two parts. One, it is mastication of the food. We are all chewing. Mastication is chewing so that large sized particles are converted to smaller one so as to facilitate swallowing. Teeth and tongue are helping in this mastication. Along with this mastication, the saliva is mixed with it. We are all rolling our food into small spherical structures called bolus so that we can easily swallow it. Along with that, the saliva is poured. The saliva is containing an enzyme called ptyalin, salivary amylase. This salivary amylase will act on polysaccharides like starch and will convert them into simpler ones called disaccharides called maltose. 30% of starch can be digested by the starch by the salivary amylase. So 30% can be digested. The saliva is containing a number of electrolytes also, like sodium, potassium, chloride and bicarbonates. Also, it is containing a bacteriolytic enzyme called lysozyme. This lysozyme breaks down the bacteria that is trying to enter in along with our food. Okay. So, food is remaining in the buccal cavity only for a short time. So, our digestion is never complete. Okay. It is only part. Only carbohydrate is digested. That too, I told you, 30% of starch is broken down into disaccharide. Digestion is not complete there. Okay. Now, the food is converted into round structures called bolus and then it is swallowed. Swallowing is called deglutition. So, once swallowing occurs, the esophagus undergoes a wave-like contraction and dilation throughout this wall. This wave-like contraction and dilation is called peristalsis. So, food is conducted. See, don't think that food is simply falling through the tube. No, food is conducted through the walls of the esophagus to the stomach. Okay, and in the stomach, the next stage of digestion occurs. So, this is the reaction that is occurring in the buccal cavity. Starch converted into maltose with the help of the salivary amylase. And the correct pH needed for its action, the optimum pH is 6.8, slightly acidic. The mucosa of the stomach has gastric glands. These gastric glands are large in number. There are modifications of the mucosal epithelium. They will be having 3 types of cells. Large amount of mucus producing neck cells or goblet cells which produce mucus. Then peptic cells or chief cells which secrete the most important enzymes called pepsinogen and prorenin. 3. Parietal cells or oxyntic cells which secrete HCl and intrinsic factor, Cassell's intrinsic factor. It is called Cassell's intrinsic factor. Okay. This Cassell's intrinsic factor is highly essential for the absorption of vitamin B12. Vitamin B12 is very essential for maturation of our RBC. So, if this vitamin is not present in our body in sufficient amount, RBC production will be reduced very much. Okay, that will be leading to a condition called pernicious anemia. The stomach can store food for about 4 to 5 hours. Within this time, the food is thoroughly mixed with the acidic secretions. How the secretions are acidic? Because you are having the parietal cells producing HCl. So, the HCl is very strong and powerful, that makes the content acidic, and that will be also helping in digestion. Along with that, the muscular activity of the stomach will be causing a churning movement. That churning movement is the mechanical digestion that is occurring. So that food is churned well and it becomes a semi-solid paste. That semi-solid paste is called chyme. The proenzyme pepsinogen. What is a proenzyme? Why it is called so? Proenzyme is an enzyme which is not active. It is not active. Why it is not active? Protein digesting enzymes are produced in an inactive form. That's a defense mechanism. If these enzymes are produced in an active form itself, they'll be immediately digesting the protein of the gland itself. The gland itself will be digested. So to avoid that, they are produced in inactive form. Such an inactive form of enzyme is called proenzyme or zymogen. This proenzyme is coming out of the gland, then some factor will activate them, and that's how the proenzyme is converted into active enzyme. This is called activation. The enzyme is activated. Similarly, we are having the proenzyme, pepsinogen and prorenin. Pepsinogen is converted into pepsin by the action of HCl. So HCl is also responsible for activation of the pepsinogen to pepsin. Now, this pepsin will act on proteins, and for this action, it requires a highly acidic pH of 1.8. The HCl also provides the necessary pH. So, pepsin act on protein in acidic medium, and now it forms the smaller subunits of proteins, namely peptones and peptides and proteases. Thus, large proteins are converted to small-sized ones called proteases and peptones. The mucus and bicarbonate present in the gastric juice plays an important role in lubrication, and also, that is a very important one, protecting the alimentary canal lining from the excoriating activity of the HCl. See, HCl is a very powerful one. It will burn and destroy our tissues. So, the HCl should not come in contact with the lining of the alimentary canal. That is done by a thick layer of mucus. That is why throughout the alimentary canal, you are having mucus producing goblet cells. These goblet cells are continuously producing mucus, so that they will be preventing the excoriating activity of the HCl on intestine. Okay. Thus, proteolytic enzyme of the stomach is converted into an active form. At the same time, HCl is not acting on the epithelial cells. Okay. HCl provide the acidic pH, that is the pH of 1.8, that is essential for the activation, optimal activation of the pepsin. Thus, food is digested partly. The second enzyme, prorenin, is also converted into active renin. This prorenin is present in the secretions of babies, small children, who are all mainly feeding on milk. This renin is a proteolytic enzyme found in the gastric juice of infants, that is acting on the milk protein casein. This casein is converted into paracasein, which will be immediately reacting with the calcium and will be forming calcium cicinate. Thereby, the protein part of the milk is separated. Once it is separated, they will be digested like any other protein. Okay. Thus, it helps in the digestion of milk proteins. Now, slowly the chyme is controlledly pushed to the next part of the intestine, namely duodenum. So, through various types of movements generated by the muscularis layer, the chyme is entering into the duodenum. In the duodenum, it is mixing with the secretion of the Brunner's gland. Brunner's gland is alkaline. Okay. Liver, that is bile. Secretion of the pancreas, pancreatic juice. Bile is alkaline. Pancreas is also producing alkaline secretion. The first secretion is alkaline. Brunner's gland is also producing only bicarbonates and water. So this alkalinity neutralize the acidity of the food that is coming from the stomach. Not only that, it provides alkaline condition needed for the action of pancreatic and intestinal enzymes on food. Pancreas is producing enzymes which are requiring alkaline medium. They will be active only in a pH of 7.8 alkaline, and intestinal juice is also requiring alkaline medium in which they will be best working. And this kind that is coming to the duodenum is now mixed with all these fluids and now become a highly fluid food which flows through the intestine. That fluid is called chyle. So chyle plus bile is called chyle. It is called chyle. Bile contains no digestive enzyme. It contains bile salts, bile pigments, cholesterol, etc., and a large number of waste materials. Remember, liver is also an excretory organ. So, materials that are all to be sent out. Some of them are produced by the liver also. So, they are all brought to the duodenum and through the intestine, through the rectum, anus, they are all sent out. So, bile is containing all such structures. It does not contain any enzyme, but bile is required for digestion. How the bile is helping? One, the bile salts are helping in activating lipid digesting enzymes. It will break lipids into smaller, tiny structures. That is called emulsification of lipids. And the digested fat is also emulsified into small droplets. Then they are all helping in absorption of the fat. Fat absorption is with the help of bile salts. Whereas bile pigments are waste products produced by the breaking down of our hemoglobin. Old RBCs are broken down and the hemoglobin comes out, which is broken down into their components, bilirubin and biliverdin, and most of them are sent out through our feces. That is why feces is having yellowish green color, and a small part is secreted through kidney. That is why the urine is also yellowish in color. Okay. Now, pancreatic juice contain a number of enzymes which are all highly essential for the digestion. What are the enzymes present in the pancreatic juice? Let us see. It contains trypsinogen, chymotrypsinogen, and procarboxypeptidases. These are all protein digesting enzymes which are all in an inactive form. When this secretion is coming to the duodenum, they will be mixing with the secretions of the intestinal juice. That intestinal juice is containing an activating enzyme called enterokinase. That enterokinase will activate trypsinogen to trypsin. Now, that trypsin will activate chymotrypsinogen to active chymotrypsin and procarboxypeptidase to carboxypeptidase. Now, all these three will act on proteins, peptones, proteases, and will be converted into dipeptides. Remember, for this action, they require a pH of 7.8. So, one set of enzymes of the pancreas. Now, the pancreas is having amylase, pancreatic amylase. This amylase is responsible for major digestion of polysaccharide, that is starch, which is converted into disaccharides. only 30% salivary amylase. The remaining is the pancreatic amylase that convert starch into disaccharides. And fat are broken down by lipids with the help of bile. That is what I told you. Bile is helping in breaking down into small molecules, small size, and then they are converted into di and monoglycerides. Lipids are converted into diglycerides and then into monoglycerides with the help of enzymes called lipases. Pancreatic juice alone contain nucleases which can act on nucleic acid, converting them into nucleotides, and during this process the ester phosphate bond between nucleotides are attacked. That is how the nucleic acids are converted into their units, monomer called nucleotides. Okay. Now they will be acted upon by the succus centricus. What is succus centricus? Succus centricus is the juice of the intestine, intestinal juice produced by the crypts of Lieberkühn. Crypts of Lieberkühn are having two types of cells, Paneth cells and enterocytes. Paneth cells are responsible for the production of enzymes that brings about the complete and final digestion. Whereas enterocytes are producing only bicarbonate containing alkaline secretion. They are all poured into the lumen of the small intestine so that they bring about the complete and final digestion very close to the epithelium of the intestine. The final and complete digestion takes place very close to the, meaning this is the epithelium. Okay. The complete and final digestion takes place very close so that immediately after digestion they will be absorbed. Let us see what are the enzymes that are present here. It has intestinal proteases. Okay. It is called dipeptidases. They act on dipeptides. Intestinal proteases are dipeptidases that convert dipeptide. What is a dipeptide? Small molecule which is having two amino acids connected together. Then they are all broken down into amino acids. Thereby, proteins are converted to the smallest unit called amino acids. Similarly, maltose, lactose, sucrose, these are all disaccharides. They are called disaccharides. These are all converted into their monosaccharide by their corresponding enzymes like maltase, lactase, and sucrase. These are all disaccharidases. Disaccharidases that will be converting maltose into two molecules of glucose, lactose into glucose and galactose, sucrose into glucose and fructose. Thereby, carbohydrate digestion is also completed. Now, the nucleic acid which are now converted into nucleotides by the pancreatic enzymes are converted into nucleosides by eliminating phosphate. By removing phosphate, nucleotides are converted into nucleosides and phosphate. You will be having nucleotides convert into phosphate and nucleosides with the help of the nucleotidases. Now, these nucleosides are acted upon by the second enzyme called nucleosidases that break them into sugar and nitrogen bases. Thereby, nucleic acid digestion is also complete. Finally, you are having di and monoglycerides of the lipids, which are all finally converted into the smallest units, namely fatty acid and glycerol by intestinal lipases. So, you are having lipases both in pancreas and small intestine, that is succus centricus. But pancreatic lipase is more powerful. Pancreatic lipase, it is also called stepsin. It is bringing about very powerful digestion for the first time. Convert them into first disaccharide, diglycerides, and then into monoglycerides. And all these di and monoglycerides are completely and finally divided into or split into fatty acids and glycerol by the intestinal lipase. The biomacromolecules are converted into their smallest unit in the duodenum region of the small intestine. And now these simple substances can be absorbed in the jejunum and ileum regions of the small intestine, and undigested and unabsorbed substances are passed into the last part, namely the large intestine. Clear? So, understand that mechanical and physical digestion, which is also called mechanical digestion, is present only in the buccal cavity and stomach. Whereas in intestine, you are having only chemical digestion. No significant digestive activity occur in large intestine. Large intestine is having no digestive glands. It produces only mucus. Abundant mucus is produced. And what are the two important activities that are taking place in the large intestine? Absorbing of some water. Most of the water is absorbed from the small intestine. Remaining water is absorbed along with minerals and some drugs, and it produces a large amount of mucus. And with the help of this mucus, undigested materials are adhered to one another. They are made sticky and they become a semi-solid paste from which water is absorbed. So they become a othering structure, and that will be lubricating for the easy passage till they are all ejected out. So they are all converted into the feces in the rectum. Undigested and unabsorbed substances called feces enter into the cecum in the large intestine through the ileocecal valve, which is regulating the flow of material and also preventing the backflow of the feces to the small intestine. You are having an ileocecal valve, a sphincter, which prevents the backflow of fecal matter. It is temporarily stored in rectum till defecation occur. Sending out of fecal material is called defecation. Activities of the gastrointestinal tract are controlled in different ways. One, neural. Our central nervous system and local nervous system are having an important role, and hormonal control for the proper control and coordination of different parts of the alimentary canal. They are controlled both neurally and hormonally. The sight, smell, or even the presence of food in the oral cavity can stimulate the secretion of saliva. Similarly, gastric and intestinal secretions are also stimulated by neural signals. So, they are all activated by the nervous system. Muscular activities of different parts of the alimentary canal are also regulated by neural mechanisms, both local and through central nervous system. We are having the nerves coming from brain and the peripheral nervous system having branches supplying to different parts of the alimentary canal. So through these, as well as through the local nerve nets, there are two local nerve nets through which also they will be controlled. Hormonal control and secretion of the digestive juice is carried out by local hormone produced by the gastric and intestinal mucosa. That is yet another function of mucosa. We are having a large number of local hormone producing argentafin cells throughout the alimentary canal. Especially they are in stomach, duodenum, small intestine. They will be responsible for regulation of the activities of the alimentary canal. Okay. Then calorific value. There may be a question based upon this part. how much of energy is coming out by the oxidation of 1 gram of a nutrient is it's called its calorific value. How you measure it? You burn them in a closed chamber called calorimeter or bomb calorimeter, and you can measure how much of energy is coming out. This is called the gross calorific value. The gross calorific value for different ingredients or components of the food are like this. For carbohydrate, it is 4.1 kilocalorie per gram. For proteins, 5.65, and for lipids, 9.45. But you won't get the same amount of energy released when they are all metabolized in our body. Why? Because some energy is always lost as heat. So the amount of energy that is released by the oxidation of these ingredients in our body, that is called the physiological calorific values. These physiological calorific values are always less than that of the gross calorific value. It is 4.0 kilocalorie for protein as well as carbohydrate, whereas for lipid it is 9.0. So remember that this value, physiological calorific value, is always lesser than that of the gross calorific value. Now, the next process is absorption of digested products. How the digested products are absorbed? It is mainly through the intestinal mucosa. It occurs always through the intestinal mucosa to either blood or lymph. Those materials which can mix with the water of the blood will be absorbed to the blood directly. For example, the amino acids, simple sugars, etc. will be absorbed to the blood directly. Whereas lipids, digested products, they are the fatty acids. They are immiscible, they are hydrophobic, they are lipophilic. They cannot be absorbed to the blood directly because they are not soluble, they are not miscible with the water of the blood. So they are first absorbed into the lymph. Okay, they are first absorbed to the lymph. How they are all absorbed? There are different mechanisms by which these ingredients are absorbed. They are absorbed passively or actively or by facilitated diffusion, that is called facilitated transport mechanisms. Normally, small amount of glucose, amino acids, some electrolytes like chloride ions are generally absorbed by simple diffusion. Remember, by simple diffusion only small molecule because it is occurring without energy from a high concentrated to a low concentrated part. It is simply by diffusion. So it is very low rate and small amount absorbed. These substances will be passing to the blood depending upon the concentration gradient. Whereas glucose, amino acids are absorbed with the help of carrier proteins, which is called facilitated diffusion. Facilitated diffusion is diffusion along a gradients. What materials? Glucose and amino acids are also absorbed. Along with that, you are having fructose also transported by facilitated diffusion. What is facilitated diffusion? Diffusion which is assisted by a carrier protein. There is somebody to assist. That is called a carrier protein. This carrier protein will be helping them. That is what is called facilitated diffusion. Whereas most of the materials are absorbed by active mechanisms. Okay. Active transport occur even against a concentration gradient because energy is needed, energy is utilized. It is uphill movement even from a low level, low concentration. it can be absorbed to a high concentrated part. So complete absorption takes place only by active transportation with the help of energy. Amino acids, monosaccharides like glucose, electrolyte like sodium are generally absorbed to the blood by this mechanism. And what about the fatty acids and glycerol? As I told you, they are immiscible with the water and they cannot be absorbed to the blood directly. They are first converted into small droplets called micelles with the help of bile salts. Fatty acid plus bile salts. Fatty acids plus bile salts. I told you we are having bile salts, sodium taurocholate and glycocholate. This bile salts will be combined with the fatty acid and will be forming small molecules called micelles. Okay, these micelles are first absorbed into the epithelial cells of the intestinal mucosa, and within the epithelium cells, within the epithelium, enzymatically the fatty acids are again made into complex molecules like monoglyceride, diglyceride, and finally triglycerides. Now, after making them into triglycerides, so for example, this is a triglyceride, they are given a coating of protein. This is the protein coat. This is the fat covered by protein coat. Now they are all called chylomicron. These chylomicrons are sent out of the epithelial cells. They are coming to the lymph, that is lacteals. From the lacteals, they are all carried through small vessels. These small vessels called lymph vessels will take them to larger vessels called lymphatic ducts, and the lymphs are finally flowing to the main veins of our body. We'll be studying it in circulation. The lymph is finally poured into the blood. Then you may wonder why it is now taken by the blood, because these chylomicrons are soluble or miscible with water. That's the technique. The fatty acids are immiscible. They cannot be absorbed directly with the blood, but they are all made into chylomicrons, which are all soluble or miscible because they are having a protein coat. So, fat, that is fatty acids, glycerol, etc., will be again reconstructed into fat, larger molecule called fat, which are given a coating of protein, and then they are all given to the lymph, and lymph, that is the lacteals, will be carrying them to the blood again. Thus, they are indirectly absorbed to the blood. Thus, absorption takes place at different parts. See, in mouth, you are having drugs coming in contact with mucosa. That is why we are all giving some emergency pills to the mouth so that immediately it will be absorbed. In stomach, absorption of water, sugar and alcohol take place. Digestion is not needed for alcohol. It can be directly absorbed from the stomach. And in the small intestine, which is the main site of digestion and absorption, digestion is completed here, and the final products of digestion like glucose, fructose, fatty acid, glycerol, amino acids and water are absorbed through the mucosa to the bloodstream and lymph. And large intestine is also having small role in absorption. Absorption of some quantity of water. Don't think that main site of absorption is in the large intestine for water. It is taking place in small intestine, but remaining small quantity of water will be absorbed in the large intestine. Some minerals and drugs also take place. So drugs can be also absorbed through the epithelium of the large intestine. So these are the sites where absorption will be taking place. The absorbed substances reaches the tissues and the tissues will utilize them for their activities, which is called assimilation. And digestive waste, which is solidified into a attaching adhesive coherent feces in the rectum, initiate a neural reflex. When the rectum is full, it will cause a reflex and our brain will send a message so that the sphincter around the anus will be dilated and you will be having massive peristaltic movement, and through that the feces material will be sent out. This is called defecation and it is a voluntary process. Why? Because a mass peristaltic movement is occurring. We are all pressing, voluntarily pressing and sending out this feces from rectum. That's why it is a voluntary process. We learn how to control defecation. Babies cannot, but as they grow, they become conditioned to this nature and it now become a voluntary process. Clear? And coming to the last part, namely the disorders of the digestive system. Normally, through the food, pathogens are easily entering. That's a common way of entering into our body. That is the common ailment to bacteria or viral. So, viruses, bacteria enter our body through the food, mainly through water. Infection also causes for a large number of worms like tapeworm, roundworm, threadworm, hookworm, pinworm. Contaminative method of infection. Through contaminated food and water, they will be entering into our body. So it is contaminative type. Along with that, you also have some other problems. Jaundice, where liver is affected. When liver is affected, we will be having larger amount of bile pigments produced, bilirubin and biliverdin, than our body can send out. So they become accumulated. That is the reason why skin, eyes, etc. turn yellow. It is a problem due to the malfunctioning of liver. Vomiting. Normally, food which has reached the stomach will not be coming back. But here, ejection of stomach content through the mouth may occur occasionally. That is called vomiting. This is a reflex action controlled by the vomit center of the medulla. There is a part in the medulla called vomit center and this is regulating the vomiting. Vomiting is also a reflex action because the food content may be having some dangerous chemical that is harmful to our body. So our stomach is sensing it and sending it out. Okay. It is a reflex action. A feeling of nausea, meaning there is a tendency of vomit, inconvenience in the stomach, etc. will be there. That's called nausea. Diarrhea is sending out of loose motion frequently. So, frequency of bowel movement and increased liquidity of the fecal discharge. Feces is liquid and abnormal frequency. You are all sending out the fecal material. This is called diarrhea. When diarrhea is there is no proper absorption. Water is not absorbed. So you will be feeling dehydrated, tired. So it reduces the absorption of the food. The opposite is constipation. The feces are retained within the column for longer time than normal. So more water is absorbed that lead to hardening of the feces. Okay. So bowel movement occur irregularly. That's the main reason whereby we are not sending out visas at the required regular periods. And lastly, indigestion, where food is not properly digested. It may occur because of several reasons. In old people, when there is no sufficient amount of digestive juices produced, digestion is not proper. Okay. Indigestion may occur because of inadequate enzyme secretion. Sometimes it may be because of anxiety. When you are all nervous in nature, anxious in nature, there is no proper digestion. Food poisoning, overeating, or spicy food. When you eat spicy food, digestion will not be proper. Okay. Then we go to the last part of our chapter, namely deficiency of nutritional or dietary materials. Dietary deficiencies of protein and total food calories are widespread. Such problems are called protein energy malnutrition, which is commonly called as PEM. Protein and energy are not available to your body in the required level. That is called protein energy malnutrition. This happened in poor countries of the world. Okay. They are of two types. Usually, PEM affects infants and small children. They will develop conditions called marasmus. What is marasmus? In marasmus, protein and calories are deficient. What are calories? Carbohydrates and lipids. Carbohydrates and lipids together are called calories. So the babies are not getting proteins, carbohydrates, and lipids. So it is normally occurring in children who are all less than an year in age. If mother's milk is replaced by too early by other food which are available in the market, which are all very poor in both protein and calorific value, this occurs. If mother is having a second child sooner after the first birth, okay, so they are having successively two births very quickly. So the first child is not getting the mother's milk to the required level, and thus deficiency of protein and calories occur that will be impairing the growth and replacement of tissue proteins. That will be causing thinning of the limbs. Skull become very small, or skull will be actually compared to that of the body size larger. Skin become dry, thin and wrinkled, just like an old man. Why there is wrinkling? Because there is no fat. See, our skin is having fat layer, adipose tissue just beneath that. That is why we become fatty, and our skins are in a fully expanded condition. When the fat is gone, that is the case when old people are having wrinkling face. Their collagen is reduced, their elastin is also reduced. They will be having reduced fat or no fat beneath. That is the reason why they become wrinkled. Even growth and development of the brain and mental faculties are impaired. Brain is not developing, not the size. The ability, IQ are very much reduced. Okay. So this is called marasmus. Marasmus is because of the deficiency of both protein and calories. Whereas kwashiorkor is a deficiency of proteins. So only protein is deficient. Calories are somewhat adequate. So there's a slight difference. Unaccompanied by calorific deficiency. There is no calorific deficiency. And this is mostly occurring by the replacement of mother's milk by a high calorific, low protein diet in child, which is common for children below 1 year. This is less than 1 year. Here, children more than 1 year in age. Child more than 1 year in age. Like marasmus, kwashiorkor also shows wasting of muscles, thinning of limbs, failure in the growth, brain development impairment, etc. will be there. But there is one major difference. What is that? In kwashiorkor, there is some amount of fat beneath the skin. So there will be no wrinkling on the skin. The face is not like an old man in babies, because already there is some amount of fat. Okay. So skin is having some amount of fat and there is extensive edema. Edema is there. What is edema? Accumulation of body fluids beneath the skin. So here extensive edema and swelling of body parts are also present in kwashiorkor. So we can distinguish marasmus and kwashiorkor by appearance of the child. In marasmus, the skin is wrinkled and there is no edema. Whereas in kwashiorkor, there is no wrinkledness, but there is extensive edema and swelling of body parts. Swelling of body parts because accumulation of fluid. That is the distinguishing feature between marasmus and kwashiorkor. These both marasmus and kwashiorkor are because of the nutritional deficiency. It occurs because of the deficiency of nutritional factors in their nourishment. Clear? So, with this, we finish the discussion of the current chapter, digestion and absorption. I hope it is clear to you. And next day, we'll be coming with another chapter on our physiology. With this, we conclude and we'll be starting the next session with the breathing and exchange of gases next time. Until then, take care and goodbye from all of us from this center. Thank you all. Thank you once again.